Hi, I'm John. I run Scale Factory. We're an infrastructure consultancy here in London. We design, build, scale, operate infrastructure for a range of companies, different sizes, different shapes, different kind of business areas. Matt throwing his phone around. Thanks, Matt. These are the sorts of companies we work for. So some large, some small, some startups, some established. All kind of interesting stuff. All taking advantage of the stuff that we can bring to the table. So I'm going to be talking today about CI in a infrastructure configuration manner. Nicky's already talked about the Terraform kind of story and where that hands off into configuration management, where they moved from Ansible to Puppet. We're also going to talk about Puppet. Really, though, I think the techniques that I'm going to be talking about are broadly speaking applicable to the other options. So Chef definitely has tooling to do this. I don't know Ansible or Salt quite as well. I imagine any of the tooling around that involves a lot of YAML, like the rest of that tool does, which is not a great deal of fun as far as I can tell. And our use case for this sort of stuff is this really. We support multiple infrastructure builds across our customers from a common set of Puppet manifests, design patterns, other types of configuration tooling. And we have multiple engineers working on that. We also have multiple distributions that we support. So right now we're supporting CentOS 6, CentOS 7, and a version of Ubuntu that we're retiring soon. We also support multiple releases. So as we develop on our Puppet manifests and we go to build something for a new customer, we kind of branch off a copy, call it a release, and then that's a supported version of that platform. As we go into a support model with those customers, we roll them forwards onto new releases as we go, so that we're not leaving too much stuff behind. But ultimately, it means that we've got a combination of things that we need to support in a reasonably long-term basis, preferably in a way that still works. So this is sort of how it looks. We've got our internal repo here in Git, where the head is where we're developing at all times. We tend to work with pull requests. So we'll create a new branch for a new bit of feature, raise a pull request. Some testing will happen. If that testing works out okay, goes green, and we merge it back in. And then as we get to a point where we're happy with the way everything fits together, we'll cut a release, and that will go into customer infrastructure as and when required. So here you can see we've got 2 releases on the go. Actually, there are way more than that are currently live. We also have 3 customers on the go. Again, there are way more than that currently live. But by way of example, customer A might be running a vSphere infrastructure on Ubuntu, which is one of the people we work with. Customer B might be on Amazon Web Services and CentOS 6, and then maybe release 2 is covering customer C, who's also on Amazon Web Services, but they're on CentOS 7. So there's a range of combinatorics going on here. And so our testing goals really are to enable fast feedback, so that our developers and our infrastructure consultants can get quick results from their changes and make sure that they're not breaking anything too heinously. And we're trying, as we're working on one customer's infrastructure, we're trying not to break other customers with the stuff that we're doing. And so we're testing around the use cases of each customer to make sure that we're not going to cause them any trouble. We also want to be sure that if we're working in CentOS 7, we're not going to break anything that was working fine in CentOS 6, and vice versa. We don't want to leave one of the distributions behind as we develop. So we also want to ensure forward compatibility. By that I mean, right now we're on a late version of Puppet 3. There is a Puppet 4 available, and so some of the testing that we've introduced is testing our Puppet manifests against the syntactical structure and functionality of Puppet 4, so that we can be sure that later on, when we roll all the customers with us onto Puppet 4, that's all going to work out okay, without us having to spend huge amounts of time making things backward compatible. We also want to ensure backwards compatibility, so as we modify some of the Puppet manifests, the Puppet modules that we're using, we want to make sure that they still retain some of the features that they had in the past if we haven't deprecated them. And we also want to make sure that the testing framework here is going to work in both a dev environment, so on my laptop, which is a Mac laptop, or on one of my colleagues' laptops that might be running Ubuntu, In some cases, Windows laptops, but that's more the customer's teams rather than ours. And so I want to be able to work locally with this stuff. But I also want to be able to submit it into a CI infrastructure. And since we're at the continuous delivery meetup, I presume everyone knows what a CI infrastructure is in this particular case. So the options we have for testing Puppets are these four, really. One of the things that we do very early on in the CI process is just a quick syntax check. So if we're checking in manifests, we're making sure that they actually validate, which is we'll catch one or two stupid things. We also run a linter against it. There's a Puppet tool or a gem called Puppet lint, which will run through all of your Puppet files and check them for stylistic rules. So, for example, the way we cuddle braces, the number of tab stops that we have, whether or not we quote bare words, that sort of thing. And the linting step is the one thing that's making our move to Puppet 4 really, really easy, because a lot of the syntactical checks that go on there are stricter in the Puppet 4 implementation than they are in Puppet 3, and the linter picks those up for us. We also have spec testing. Spec testing in the Puppet world is similar to spec testing in Ruby. Does anyone know spec testing in Ruby? We work with RSpec and those sorts of tools. So RSpec allows you to write tests that assert certain things about the Puppet catalog. I suppose I should describe what the Puppet catalog is, really, for those of you who might be less familiar with the tool. Puppet's a desired state configuration tool. It's declarative in the same way that Terraform is, and so we describe what we would like the infrastructure that it's configuring to look like at its end state. When we run Puppet, it takes that description of the end state and compiles it into something called the RAL, which is a resource abstraction layer. In computer science terms, it's a directed acyclic graph, and it takes that RAL. It builds a graph of the current state of the infrastructure, compares the two, works out the changes that it needs to make in order to go from the current state to the desired state, and then makes those changes. It's idempotent as long as you've written your manifests properly. So if you run Puppet a second time with the same catalog, it will not make any changes because you're already at the desired state. So our spec testing in the Puppet world, we can work entirely on the RAL rather than actually doing anything with real infrastructure. So we can start up an instance of the Puppet code. We can set up a fixture that contains an example of what the current state of the machine is. We can compile our catalog and make sure that compiles. Then we can apply it to the graph, and then we can make certain assertions against the graph. So we can say things like, there must be a package called this installed, there must be a port in the firewall open called this, and all that stuff is pretty quick because it happens entirely in memory inside the Puppet interpreter. Doesn't start making any changes on the infrastructure. And that has a certain amount of value, but it's not a true integration test. So you can write Puppet that passes spec tests, but that actually will blow up on the machine because perhaps you've written a config file for Apache that's actually invalid as far as Apache is concerned. So valid Puppet in the spec may not necessarily confer to valid state on the machine itself. And so there's integration tests as well. And they take substantially longer to run, and I'm going to talk about those in slightly more detail. And these are the sorts of times that we're talking about. So the syntax check of our manifest set can take about 26 seconds, so we can do that on check-in without that being too onerous on every pull request and every new branch that we create. Linting, again, pretty quick because that's just parsing of text files basically and comparing rules. The linting tool also provides you with a fixer. So if you're linting an entire code base, you can make it fix some of the stuff for you, which makes adding that quite straightforward to an existing set of Puppet. Spec testing takes a little longer. Our spec tests currently don't have a huge amount of coverage, but some of our newer testing uses spec tests in order to accelerate the testing process, and that currently runs in a couple of minutes. So again, it's not onerous. It's not a process that's going to take an awfully long time. It's something that you can run on every check-in without that really disrupting the flow of the people that are working. Integration tests, however, take about 6 hours, or between 6 and 9 hours, depending on the prevailing winds and sort of upstream package repositories and those sorts of things. So obviously we don't run those on every check-in because that would be insane, but we do run nightly jobs that test the integration. And the integration tests give us arguably the highest value in terms of what's actually going to work for the customer. But because it's such a long process, we don't get immediate feedback from that. So one of the things that we do is we wire our Jenkins service into Slack. This is, you can see a pull request being raised by my colleague Mike Mead, who I think made some kind of logic error after he came back from holiday because he'd spent too long away from Puppet. He fixed that. I merged the pull request, then Jenkins kicks off. So if you're using CI with your chat service, you're probably familiar with this sort of workflow. It means that we get very quick feedback as to whether or not that pull request is syntactically valid, if it passes its linting, and if not, then obviously you can go away and fix that before we go any further. The integration testing mechanism we use incorporates Vagrant, which is as we've discovered earlier, a HashiCorp tool. They're first, in fact. Vagrant is a hypervisor manager, if you like. It's a command line tool around describing and then running environments of multiple machines, multiple virtual machines. And so we use features of Vagrant to provide ourselves with a small cluster of machines on every build server on the Jenkins estate, and that Vagrant setup is going to be where we run our Puppet manifests in order to check for them for their validity in terms of integration. And we do that with a tool called Vagrant Cucumber. So Vagrant Cucumber predates tools like Beaker and Test Kitchen. It's something that we wrote some years ago. It's basically a tool to wrap Cucumber, which is a Ruby testing tool. Anyone familiar with Cucumber? BDD testing kind of style thing. This is the Ruby implementation of Gherkin, which is the language. And Vagrant Cucumber allows you to call that in a way that also gives you access to the Vagrant objects in the Vagrant binary. So we can start a virtual machine and we can then interrogate bits of it from the Cucumber feature files. So this feature here is an example of a very straightforward, can we run NTP with the default configs? So if you're not familiar with the BDD language, we've got this description of the feature at the top here, which is a sort of friendly thing that isn't interpreted in any way. We've got a scenario here called NTP client installation, which is again an indicator of the name of the scenario. It's not used in any kind of programmatic way. Everything underneath the scenario there is interpreted programmatically, and so there are step definitions that allow us to interpret, given there is a running VM called server, and when I apply a Puppet manifest containing, and these are the other check things down here. I've got a brief example of the VM step. You can see here there's a regular expression match at the top where we're looking for a string starting, there is a running VM called. There's a regular expression match here that we're going to use as a parameter. And then inside the definition of that, whenever we see something that matches this running in the spec definition, we're going to call this code here. And this calls into a bit of the Vagrant Cucumber library in order to pull out a Vagrant object for that VM, and then we can ensure that the VM is up, and then we can snapshot the VM itself if we haven't already taken a snapshot. And we'll talk briefly about the utility of snapshots in a second. Here's another example. This is the Puppet step. So for lines matching, when I apply a Puppet manifest, this is an expanded regular expression snippet that allows me to say on a machine called, or on the last machine, or something else English language style. So when I apply a Puppet manifest on the current server, is what the default's to, containing manifest content, Then we have this little block of code here that calls out into some more of my step definition that's defined up here and a bit more involved, which connects over an SSH channel to the VM itself, runs the Puppet manifest, and then does things with the return values so that we can say whether or not that worked properly. So we're checking this exit status here. We check against 2 values because Puppet's a bit weird with what it returns. And then we can use all the test unit stuff. If you're familiar with Ruby testing, there's a whole suite of assertion methods that allow you to compare the results of things and make sure they look the way you intend. So that's the briefest introduction of implementation of this stuff. A slightly more involved test might look a little bit like this. This is a section of a Cucumber test for spinning up a MongoDB cluster, establishing that cluster, and then making sure that data that you put in one node goes into the other. We're doing some slightly dirty stuff here by running a shell command in a big line here. It's better practice to implement some of these sorts of checks as Ruby rather than shell lines, but in a pinch you can do the shell variant. And so this tests that given multiple machines, we can check that a Mongo cluster works okay. So for every test scenario, we start up a batch of Vagrant boxes, and then for every test, we're going to snapshot the box, run the scenario on it, check the results of it, blow up if it didn't work, otherwise carry on, and then roll back the state of the VM. So we always start with a virginal box, and the Vagrant box is based on an image that we build using Packer that follows the same conventions that our Packer script use for creating Amazon AMIs. So the image itself comes up already has Puppet installed, and that's the bare minimum that we need for these tests to be able to run. That's the bare minimum that we need in our production environments as well. Cucumber can also spit out an HTML report. You see this is in the nightly job. Don't know if you can see the numbers. That's 4 failed tests. That number gets smaller all the time, which is good, generally speaking. And the nightly job runs against several branches and all of the combinations of Linux distribution as well. So we get a test against the most recent stuff on CentOS 6, most recent stuff against CentOS 7, and so we can come in the morning and see what's failing. The CentOS 7 work is work in progress at the moment, so that's why you get these reduced number all the time, but we're nearly there. And these menu items all expand, so you can see the output of the run. You can go back and see when something failed, and hopefully reproduce that in your local environment and go and fix that. So the challenges of this approach, VirtualBox was the main challenge for a while. VirtualBox used to be really shoddy and would either hang the machine or would just get stuck. We've done a certain amount of stuff around the use of VirtualBox and Vagrant in our test jobs to sort of try and recover from certain failure states. These days, VirtualBox is actually pretty good and its performance isn't bad either, and that used to be a major issue for us. The other main problem that we've had in the past with this sort of testing is where you're using remote resources. So for a little while we were using external package mirrors, and so you get in the morning and find that a certain number of the tests had failed, and it turns out that's because the package mirror wasn't available at the time. And so we put a lot of time into building local mirrors and making sure that we can express an upstream mirror in our Puppet manifest, but also ask Puppet to configure a mirroring tool to fetch those things down. So that runs on a nightly basis before the test jobs run, so that we're using entirely local package mirrors. And that means that not only are the mirrors a bit more reliable, but the tests also run much quicker as well. So that 6 hours is down from 11 or something, which was quite heinous. The other challenge that we've had, that we've recently resolved to our satisfaction, was the parallelism of these test runs. So it used to be the case that we could run on a single Jenkins build node, we could run just one suite of tests against one cluster of machines. And we found that if we were not doing that, the VMs in different test runs would interact with each other. And David, who works for me, has done a sterling job on root causing that. It took him a little while, but we established that the reason was that the private network that was stood up by Vagrant for the VirtualBox VMs was the same network across both clusters of machines, and so these machines were talking to other nodes with IP addresses that had the client IP address, but actually it was talking to this other set of machines over here. So we've done some stuff that involved getting a pull request upstream into Vagrant, which was released recently, to allow us to actually segregate those networks. So the test networks have the same IP address ranges, which we sort of rely on for some of the tests, and but they don't interact with each other because they're on separate virtual networks, separate broadcast domains. Actually, the biggest challenge in testing this stuff is knowing what to test. There's a lot of stuff on the interwebs about how to test infrastructure, how to test configuration management tooling. The majority of it is how-tos and blog posts from people who've set the test tooling up, and then haven't really got any further with it because it's been too hard or they've had other things to do. So there's a lot of stuff out there about how to set Beaker up. There's a lot of stuff about how to set Test Kitchen up, about how to set Server Spec Hub, but there's not a lot of knowledge out there about what is a good way to test this stuff. And so we've had to kind of come up with our own lore, L-O-R-E rather than L-A-W, about what it is that we're trying to achieve with these sorts of testing. First up, we're not trying to test that Puppet works. So if we've got a Puppet manifest that says install this package, there's not really a lot of point in us having any testing that says is such and such a package installed. That's kind of a given. Usually speaking, you're not writing a manifest to install a package, you're writing a module to run a service. And so the type of testing that we're aiming to do in the integration tests is this service running? Is it returning results in the way that we expect? So a lot of the kind of the blog posts you'll see will do that basic. Oh, I've installed a package. Is there a package installed? But everything's tested, which doesn't really give you any kind of value. And so we're testing a bit deeper than that. It's important, I think, to cover branches rather than complete code coverage of your manifests. And what I mean by that is, for example, our Puppet manifests have conditionals in them that say, if I'm running on CentOS, then here's some things that we need to do. If I'm running on CentOS 6, here's some things I want to do. If I'm on CentOS 7, here's some things I want to do. And so what we're trying to do with our test harness is to test each of those conditions. The other type of thing that we test, each module has a parameter interface, and depending on the complexity of the module, there might be 20 or 30 parameters. What we're aiming to do is to test the sensible variants of each of those parameters. So we're going to spin up our cluster, poke some parameters in that look like a real workload, run those tests, see whether or not the services respond the way we expect, roll everything back again, poke some new parameters in, and do it all again. And we try to do that so that we can guarantee that the use cases that we covering all permutations of all parameters. We can do that in spec testing with reasonable speed and with reasonable guarantees. But for the integration tests, which take a lot longer, we're trying to test the things that we've actually seen in real life. So we're trying to be pretty pragmatic about it rather than purist about it. The other things that we aim to test are things that break often. So anything that is liable to going wrong if we're poking around in it. Those are things that we wrap more tests in. As we see new failure conditions, we can put tests around them. And things that are complicated or complex, either of those. For example, we've got a bunch of auth configuration that writes PAM configs, and we have PAM configs that work for YubiKeys and SSH logins and a whole bunch of other stuff. And PAM's kind of complex. And also you look really stupid if you deploy something to a customer's site where PAM is installed but isn't really checking passwords, lets anybody in, which is entirely possible. We have such distrust of PAM, in fact, that our Slack channel, or Slack bot, if we type PAM in there, it comes up with the animated GIF of the guy who comes naked out of a hotel room with his tray and puts it down, turns around to find the door locked behind him. That's the sort of thing that PAM can get you into that kind of trouble. That's about all I've got to cover. I appreciate it's a bit brief. Matthew asked me to do this last week in my defence, but I will answer any questions you have about the places I've been a bit less clear than you might like. Yes?
Just curious if you tried KVM instead of Vagrant at any point?
So Vagrant wraps different hypervisors, and so there is a KVM backend implementation for Vagrant. In theory, that will work as long as the snapshot module that we're using supports KVM snapshots, which it doesn't because I wrote that and I haven't supported that provider. It works across VirtualBox and VMware. And the snapshot module also supports Hyper-V because I fancied a bit of a challenge on the weekend, but we haven't tried the test suite across there. It shouldn't matter what Vagrant is actually running against, as long as it provides that SSH interface and the rollback, snapshot and rollback process. Then in theory, Vagrant Cucumber will just work on it. But our use case is VirtualBox for the most part. I run VMware on the laptop because some of our customers do. It's good to find out if things break on there that the customers will find. But yeah, ultimately it doesn't matter what Vagrant implementation you're using.